Okay. Welcome everyone. This is the Pandas tutorial, and I'm your host, Stanley Hua. Um, and before I begin, I just want to let you know that this is a practical introduction to Pandas. I'm not going to be delving too deep into uh, why Pandas works, but instead I'll be teaching you how to use Pandas as a tool and how to use it to answer questions that you have about your data. Okay, so why Pandas? It's because real world data is messy and not all the time it comes clean. So we need a tool for manipulating our data. And also at the same time, Pandas is very fast and scalable because it's built on top of NumPy. Yeah. Okay. So for today, I'll just be spending the next 5 to 10 minutes uh, doing a brief introduction just to get you familiar with some stuff in Pandas. And then we'll proceed directly to the tutorial where we'll be spending most of our time understanding specific commands um, and ways you can answer questions in Pandas with a lot of examples. And then after that, um, there's an optional 10 minutes um, where you can answer these practice questions at the end of the tutorial section. And that'll be completely unrecorded, but you can ask us questions um, any questions you have related to the problems. Okay, so first I want to talk about data types. What types of data Pandas expects in their tables? And this is also abbreviated by the word dtype. So there's integer, float, bool, string, and etc. But as you can see, there's an extra. There are extra Pandas dtypes that aren't native to Python, such as datetime, which tells you the date, and also object, which is if your table or your column has more than one dtype in it. And this will be very important later on for when you try to apply functions to your columns, because you need to know whether or not your function is full of integers or whether or not it's full of strings or if it's full of datetime objects, and that'll influence how you process these columns. Okay, so now we'll be talking about the Pandas classes that you're definitely going to have to use. Starting with the most important, which is the data frame. It's pretty much just a table of values with column headers and row headers. And if you look at this example, you can see that the column headers are sepal length, sepal width, petal length, petal width, and species. And then these are the values contained within your data frame. Data frame is just a fancy word for table, but there's a lot more utility or a lot more terminology that you'll have to get used to. Personally, I like to think of these data frames as lists of lists. As you can see over here, this is a list containing 3 different lists, right? But you can also think of them as stacked lists like this. And when you input this into Pandas, Pandas recognizes it as this type of table. And pretty much that's the way I want you to think about data frames. There are a bunch of rows that are grouped together. And each row is an example. If you look here, this row here represents a flower, right? A flower of the Setosa species with petal width of 0.2, petal length of 1.4, sepal width of 3.5, and sepal length of 5.1. And the same can be said for the rest of these. Each row represents an example, and that's the way you should address a data frame. Now, the next Pandas class that I want you to think of is series, which you can think of as a row or as a column of these Panda data frames. If you look over here, this sepal length column, this can be considered a series object. And the data set is made up of multiple series objects. But in this example over here, we take a slice of the row instead of the column. Okay, so so in the Pandas series, the indices or the indexes, the row indexes, are sepal length, sepal width, petal length, petal width, and species. And here, these values on the right represent the values that are attributed to these indices. Okay, so if you look at this example too, you'll notice that you can actually build a data frame with series objects with these particular indices. So this would be one series object or 5 series objects that are concatenated into one data frame. Okay. And something interesting is that you can think of data frame, you can think of images as data frames as well. And if you look here, you can see this 2 is pretty represented by the pixel intensities in this data frame, where these are the rows and these are the columns. Okay, next, I want to talk about messy data. What makes data annoying or hard to work with? And some examples. So messy data is data that simply isn't ready for analysis or exploration. If you try to use any pre-processing function that you can think of, it's likely that there's going to be an error with how you handle the types. And that's why we need to first clean our data. Some common problems include having missing values in our table, or none, or missing or ill formatted data. And as I mentioned here, you can also have data which is improperly structured. Like it's not completely an integer, or it's not a string, but you'll have to parse it in order to understand what it actually contains. And lastly, these are just examples, but one very, very important example is misannotation. If you misannotate the data in a way that is logically correct, it's going to be impossible for the person analyzing the data to be able to know whether or not this was misannotation or if this was inherent to the data. Okay, so for missing values, as you can see in this table, which is similar to the one I showed you a while ago, it contains these NaN, which means not a number, or these none values. What it represents is there simply being no value in these cells. And this is going to be a problem, especially if you try to do anything with your data, because your function cannot accept a null value. Okay, and another example is having duplicate rows. If you have examples which are actually the same, then your analysis would be biased. For example, here, you can notice that this row and this row are duplicates. They have exactly the same values across the columns. And same with these two values. Okay. All right. So that was a brief introduction. And next, we'll be diving straight into the tutorial, where I'll be talking about other questions that you can ask and answer using pandas. Okay. Also, I'll be taking a couple of minutes and allowing you guys to access this link. And I'll also put it in the Zoom chat so you can access it. I recommend taking a copy of this Google Colab and putting it in your Google Drive. So while I work on it, you can also work on it with me if you'd like. Okay, let me just delete these tabs. But yeah, okay. So now this is the true Pandas Workshop, where I'll be talking about different methods that you can use in order to understand your data. Specifically, we're going to talk about 4 categories that I made up. One section is going to be about reading and writing files. The second section is going to be about basic data exploration, just understanding what exactly is in your table. 3 is going to be slicing and Boolean filtering, where you specifically choose what part of the data you want to look at. And 4, and I think this is going to be the most important one, is basic data manipulation and cleaning. And here you'll understand how you exactly apply functions to your tables to use the values in your table for a meaningful purpose. Okay, so first we're going to start with importing the libraries. As you can see here, I import the library as import pandas as PD, and PD is a simple convention that is used and is most frequently used by most people, and it's much shorter, so that's why it's easier to remember. And we recommend that you also use this formatting. But before we begin, I wanted to show what I meant earlier by the way that Pandas can read lists of lists as a data frame, similar to how I showed it a while ago in my slides. Okay, so as you can see, these are 3 lists with increasing indices. Okay, what I'm going to do is I'm going to create a data frame using this function. And I'm going to call the data frame df. This is another convention that I want you to get familiar with or used to, as this will be used in most resources that you look up. So this is how you create a data frame. PD dot data frame, and then you put in your data here inside the brackets. In our case, we're going to use list 2 and list 3. Okay, and this is what it should look like. As you saw a while ago, this list here would correspond to the first row. This list would correspond to the second row, and then this list would correspond to the third row. Okay, so I hope you have a general idea now of how data is stored and how you can interpret data frames from an intuitive understanding. Okay, so now moving on to reading and writing files. Here is going to be the most one of the most important parts to your data science project, where you'll need to understand how you read in the data, and also like what data you're working with, right? So here's some useful things to think about. You need to understand first how your data is stored, what the format of the file is, if it's a comma separated value or a CSV file, or if it's an Excel file, or perhaps if you're reading a data table that's stored in the website, you can use read HTML. And there are several other file types that you can use, but I'm just listing a couple which will be the most important, most useful to you, or the most common file types that you'll most likely come across. Next, you also need to think about if the file is compressed. You can't just read it straight off using this, but if it's zipped, you'll need to use an optional parameter in order to read your data. Okay, so now let's look at an example to understand this. We'll look at what animal can you beat in a fight data set, and it's located at this URL. So since I put it here already, here this data set stored as a CSV file, although it's not put here, but on the website it's stored as a CSV file. So we're going to read it in as df equals pd read CSV. And there you go. Oh wait, whoops. Let me never mind. I think this might be an Excel file. No, this is an Excel file. Okay, so you'll actually be using read Excel. Read Excel. Okay, so I think it should work fine now. Okay, so let's take a quick look at what this data set contains. And you can do that simply by putting in the data frame and just pressing run, and it should show you what the data frame holds. Here in this case, in this data set specifically, there are 4 columns: the animal column, total column, male and female column. And all it's telling you is how much the males believe that they can beat up a rat or a house cat or a medium-sized dog, etc., or how much a female thinks they can beat these types of animals. But okay, now let's say that you've done your pre-processing and you want to save your work. This is another command that's going to be very useful to you. And I miswrote it here, so I'm going to fix that right now. But this is actually supposed to be data frame. You'll be directly exporting your data frame to a file location. So now that we have this object called df, we can use the command df2csv and supply it a name, including file format. So let's say I want to name this abc.csv. And there we go. It saves it directly to my Google Drive since I'm using Colab. But if you were on your computer, it would save it to whatever directory you're working in. But also I want you to notice that initially we started out with an Excel file and we read in an Excel file, but we saved it as a CSV file. And that's one thing that you'll also have to get used to, is that you can actually save it into anything that you want after you're done with it. So you don't need to be limited to CSV or Excel or anything like that. But okay, now that we have our data, let's take a look. Let's take a look at let's take a look at what actually is in the data, as I mentioned. And we can ask a couple of important questions. One, what is the shape of my data? And this includes how many rows do we have and how many columns do we have? So you're essentially asking how many examples do we have and how many variables do we have? And you can get that using df shape. So I'll do that very quickly. But also, I forgot, but it seems that I also loaded in another data set. And that's going to be this one. So this one's located here at this URL, and I'm going to load it in this time using CSV. Okay, so now that we have this data set on crime records from data world, we can explore it using these, using df.shape first. And this tells us that we have 270,000 rows and 10 columns. And if you take a look at it, that's exactly right. And when you print it out, it also shows you the shape at the bottom left. That's also something to consider. But okay, another question that we can ask is, what does the table look like? And as you see over here, I printed it using df, but by automatically, it shows you the first 5 rows and the last 5 rows. However, this is similar to using df head, which shows you the 5 rows, the first 5 rows, and df tails, which shows you the last 5 rows. And sometimes this could be important, especially if your data is organized by dates or something similar to that. Okay, now the next question that we can ask is, what data types are present in our columns, as I mentioned earlier, because this will influence how we deal with our data. And okay, so you can use df.dtypes if you're working with a data frame, and it looks like this. So here on the left side is the column variables that we have. We have this unnamed column, crime, number, date, location, whatever beat is, neighborhood, NPU, latitude, longitude, and these on the right side correspond to what types of variables you'd expect to see. So with number, you'd expect to see an integer, and you can treat it like so. With crime, you see object. So this most likely means when you see object, you should think right away string, or it could also have like multiple things, but most likely it'll be in string format. Okay, so here it shows you the column names as well, but there's also specific commands so that you can see exactly what are your column variables and what are your index variables, or what's on your rows, what indices are for your rows. So as I mentioned, these are the columns, and you use df.columns in order to see what are the column names. It's very intuitive. And you use df.index in order to see what are your indices. And here it provides a range object, but it's much easily said as it's from 0 to 270,000 and everything in between, right? Okay. So next you can ask, are there any missing values in my table? As I mentioned, you can have nones or objects like these in your table, which just means that you lack a value in that specific place. And you can do that using df.isNA. And here it should show you, it'll ask every single cell in your table whether or not it's a none type or not. So here in this case, you'll notice that in these specific cells, it says that these are true. which means that these are actually non-types. So they don't actually contain a value that you can use. And later on, I'll show you how to remove these non-types. Yeah. But also, you can use this. You can use another command. You can sum it up across its rows. So you can sum up the number of NAs that you have here, and it should return you. It should return you the number of NAs per column that you have. So essentially, what happened here is that this df.isNA output this data frame full of falses and trues, and the trues also signify for ones, while the falses signify for zeros. So when you pipe it to sum, you'll notice that it'll sum across each column, and that'll give you a number with how many NAs that you have per column. So in this case, when you do that, you'll see that neighborhood has 11,000 missing values. And depending on your use case, that might be very bad. But in any case, next you can ask the question, how many do my columns have unique or repetitive values? And this can also be important whether or not you're talking about groupings, if your data is grouped in a specific way. So let's first take a look again at the data. If you can see, it looks like neighborhood contains values that should repeat, and also crime, because this is a data set for crime record. So there's going to be crimes that repeat, right? So you can use n.unique in order to understand how many unique values you have per table. And as you can see over here, there are 11 unique types of crimes that you can commit, apparently. But also, you can use value counts to understand the same thing, pretty much. But actually, I would prefer that you use value counts when you're looking at a specific column, because what this tells you is what values appear the most, essentially, or like what values do you see? How many times do they appear? So for now, I'm going to brush over this, but I'll discuss that very quickly. So I'm going to select the crime column, and I want to see what values are present in the crime column and how many times do they exist. Okay, so if you look here, these are the 11 crimes that are being recorded, right? So there's larceny, and it's also sorted from the most number to the least, most number of occurrences to the least number of occurrences, and that starts from larceny all the way down to homicide, right? Okay, so let's answer these questions. And I think I've already answered these questions. Are there any missing values in the table? And from a while ago, I answered that using this function, which is df.isNA.sum. So now we know that there are this many missing values in the table. Okay, now how do we know about duplicate rows? So there's another command called df.duplicated, which works very similar to the other commands. And when you run it, it tells you whether or not a row is a duplicate or not. And as I mentioned a while ago, the row would be a duplicate if it has exactly the same values across the entire row. And also I've answered this question, which is how many unique crimes have been documented? And I answered that using df crime dot value counts. Okay, so now it isn't always reasonable to just look at the data set by printing it. And as you can see from this one, sometimes it gets cut off because there are way too many variables, and there are also way too many rows that you can't print the entire data frame and show it in your console. So it's sometimes useful to only take a look at parts of our data set. And also, similarly, we also need a way in order to access only some parts of our data set which we want to edit or use. Because you can't always just use the entire data set at like one point. So consider the following questions. in case there's any particular interesting columns or rows that you want to look at, like I mentioned over here, where I had to choose a specific column, you'll need tools in order to be able to choose which rows or which columns you want to look at. And also similarly, if in case you need to change or assign a new value to a column or like specific cell. Okay, and this is called slicing, where you select rows or columns through indices, through indexing. And the first method that I'll show you is by column name. And I've already shown you it using the above example. But okay, so here's the following syntax. There are two ways that you can do it, where you can look at one specific column or one group of columns. But for one specific column, you can put the list bracket, and then inside of it, you put the column name. And a while ago, we saw the column names by using df.columns, right? So for example, if I wanted to look at neighborhood, then I would use these brackets, and then I would simply put in the name of the column. Oh, I misspelled it. Okay, and it'll show you that column. And one thing you'll need to think about too is, are you looking at this data frame? Like specifically, is this data frame what you're accessing? So right now, when I call df.neighborhood, what I'm actually looking at is a view of the data set. So I'm actually looking at a column from the original object. So if you edit this column, it's going to directly affect the data frame. But okay, so going back on track, another way is using this dot. And it's actually very similar to this $sign that you use in R, in case you've ever used R before. And all you do is you use a dot, and then you put in the name without any quotation marks or without any list brackets around it. Instead, you'd just be using this. But this wouldn't work for variables with spaces in their names. For example, this unnamed variable over here. So this unnamed variable would look like that. But when you run this, it doesn't work because there's a space in between, right? So this is why you need, in these cases, you would need to use these brackets and the quotation marks around it. But okay, you can also feed in a list of column names in case you wanted to look at multiple columns using their column names, right? And you can use that, and you can do that by creating a list of column names and putting that into the using the same formatting as I showed you a while ago with the brackets. And all you have to do is just put this column variable inside the same formatting, and what you're going to get is a view of these two columns that you wanted to look at, right? Okay, so you can also use this for assigning columns. So here I'm asking if you can create a new column notes on data frame, right? On this object, right? And you do that similar to as how you accessed it, except this time you just put in the name of the column that you want to put in, right? So in this case, it's df.notes, and I'll put in an empty string just for an example. And now if I load in the data frame, you'll notice that there's this notes column because I updated it. Okay, so next, locate by index name. So now this method is good for checking out column names, but in case you wanted to look at specific rows by its index, like for example, if you wanted to look at the first 10 rows, then you'll need to use dflock or the next command. But in this specific case, what you need to pay attention to is what are these values on your rows and on your columns, right? Okay, so in this case, you'll have to use indexers. Oops, you'll have to use indexers, and you'll feed that into this format, right? And I'll just show you by example so you understand what I'm talking about. In this example, I'm going to select the first 11 rows, and show the columns crime to location, right? So if I open the data frame again, I'll need to show from crime to location. So in order to do that, I use lock, and then from the 0th row, or I can omit the 0, from the 0th row to the 11th or to the 10th row, I'll select that, and I'll also select from crime to location. And as you can see, this is exactly what we get. But one thing also that I want you to pay attention to is that indexing in Pandas is inclusive, whereas in Python it's exclusive. So with slicing here, you'll notice that I go all the way up to 10, right? And here we actually include the 10th row. Whereas if in Python, if you did let's say 1, 2, 3, 4, 5, and then hold on, if you do this, and then you index it until, let's say, the fourth variable, which is this one, it'll only go until the fourth one. But in this case, with df.lock, you actually include everything. So that's something you also need to keep in mind when you slice your data frames. All right, so next is locate by integer position. So instead of using the names explicitly, you completely forget the names, and all you think about is their position. And this is actually somewhat similar to Python, because the indexing is strictly by integer position, right? So, okay, so as you can see, this is I'm asking for the same thing, but this time I'm going to do it using ilock. So based on the integer position, starting from 0, this is going to be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, right? And the rows would be 0, 1, 2, 3 up until 10. So if I try to follow the last one and I do it similarly, so this is 1 since I'm going from crime, 2, 3, 4. I'm trying to do it as similar as I can to the last one. You'll notice that I actually lack a row and I lack a column. And that's because the ilock is actually exclusive. So here you'd have to think back again to Python, where it doesn't include the last thing, right? So I'd have to add 1 to the ends, and I get the similar thing as I did to the last one. Okay, so very quick aside, you need to be very careful about what exactly is a view of the original data frame and what is a copy of the data frame. So if you look over here, what I'm doing here is I'm chaining commands, right? And this is the cool thing about Pandas, is that after it outputs something from a previous command, you can chain it immediately to another command, right? But you need to be very careful about this, because sometimes, and it's hard to predict, sometimes it'll give you a copy of a data frame. It'll use a copy of the data frame to create what you're seeing, right? So if you try to do this, and what I'm doing here is I'm selecting all of the columns and all of the rows normally, and then I select the column again following it. If you look at it, it looks completely normal. But the problem is, if you say you want to like assign 5 to the entire column, and you do it this way, this actually doesn't do anything, because what you're doing is you're assigning 5 to a copy of that data frame. You're not actually editing this data frame. And I'll show you the data frame just so you can see it. But as you can see over here, nothing was assigned. And that's something you need to also think about. So that's why I would recommend against chaining commands if you can help it. And it's not very clear cut. So if you want to read more about it, I left a link here, but I'm not going to spend too much time on it. Okay. So next thing is conditional filtering, which is you're only looking for specific rows in your data set which fulfill a specific condition. And you do it somewhat similarly to the other ones, where you use the other commands. What you're doing here by IDX is you're evaluating the data frame or you're evaluating like a column for a specific condition. And I'll show you through an example. So say we want to look at criminal records that took place on February 12, 2014. So first, let me just take a look at the data set. Okay, so if you look at the way that the data is formatted, what we're actually looking for is 0 to 12 and 2014. So what I'm saying here by Boolean indexing is we're going to compare the date column. So we're going to compare all the rows in the date column with this specific value, right? So I want you first to look at what this outputs. This is going to output false for everything that isn't this, but true for everything that is this, right? Okay. And just so you know what it looked like beforehand, this is just date and it compares it to each single part, right? Okay. So now let's say I assign that to IDX. I'm just going to put brackets around it so it's easier for you to look at. Okay. So now if we feed IDX or index into the data frame, it's going to give us all the rows with the date as given, right? And what it's actually doing is it's checking this IDX for which values are true, and then it only takes the values which are true and uses that as the index. So that's what Boolean indexing is. But note that you can actually do this without completely ignoring this variable assignment, and you can just move directly to this. And that's up to you, but I think this looks much cleaner if you put it in a separate line. But okay. Okay, so next is query, which is actually very similar to Boolean indexing. Because what you're doing in Boolean indexing is you're comparing a column with a specific value, right? But with df.query, you put it inside the function or inside the query what you're looking for. And this time you don't actually have to include a call to the data frame such as this. Okay, so let me give you an example. Say we want to query the data frame to find all crimes done at downtown. Oops. Okay, so you'll need to use a string query, right? Okay, so what you'll do is first you'll have to put your column name, which in this case is neighborhood, and then you'll do the same thing that you did with Boolean indexing, but this time you'll just put it inside a string. Okay, in this case, we're going to be looking for downtown. And as you can see, it does exactly what you want. In my opinion, it doesn't really matter if you choose Boolean indexing or query, but these are just two ways to do the same thing. But yeah, okay. So now we're gonna get into data manipulation and cleaning. So now we're gonna start talking about how you apply functions on these columns. But before that, does anyone have any questions regarding anything that I've talked about so far? I'll give you 1 minute. All right. If there are no questions, then we'll proceed directly into data manipulation and cleaning. Okay, so similar to numpy, Pandas allows us to apply functions across arrays. So what that's essentially telling you is if you have a column and you want to apply a function to it, then you can. Or if you want to apply a function row-wise, then you can, right? Okay, so and there are a bunch of commands that I'll be teaching you so that you can maximize these vectorized operations or that make use of these vectorized operations, right? But you also need to think that all of these vectorized operations, by default, they do not touch the original data frame that you specified. They actually give you a copy of the data frame that was under that function, right? Like if you pass the data frame through that function, the output is just going to be a copy. It's not going to affect the original data frame that you had. Okay, so the first one I'll be teaching you is df.count. This is just telling you how many values you have that are not NAs. And this is something that I did similarly a while ago. Actually, and it's already over here. But as you can see, these are the number of values that you have in each column. And if you look at these ones are actually less than, like for neighborhood, NPU, whatever that is, these have less non-NA values than the other columns. And this is similar to what I showed a while ago, where these columns had NA values. So it's almost the same thing. Okay, so now we'll be talking about operations on numerical columns. These are columns with type integer, right? So if you have a column full of integers, you can only apply, or you should be applying these kinds of functions towards it. Because it doesn't make sense to sum across a column of strings, because that doesn't make a lot of sense usually. And the commands that I'll be showing you is dfsum, max, min, mode, mean, and variance, in case you care about that. But yeah, so now I'll try to, okay, let me just remove this. But I'll try to answer the question: at what latitude and longitude do crimes happen the most? So when you say the most, of course you mean the mode, right? So first I'm gonna access. Actually, for now I won't access the specific column, but I'll run what df mode shows, and here it shows another data frame. And the reason for that is because one of the columns here has more than it has more than one mode. In this case, there are multiple modes because each single number in here is unique, or well, most of them are unique at least, right? And I'll just show you for the sake of it. But if I call df.sum, it should give me an error. It should. That or okay. Anyways, I think it's gonna take too long to summon, so I'm gonna try to cancel that. Okay. Huh. Well, that's awkward. Okay. You know what? Let me just restart that. Might have been too much, but okay. So I'm gonna try doing that again. Let me just check if my data frame is loaded. Okay, it's not loaded. So let me just reload everything very quickly. So I'm gonna import pandas, and then next I'm gonna import my data. Okay. 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 So now I'm going to actually let me just check very quickly. What are my columns? And these are my columns. Okay, so lat corresponds to latitude. So I'm gonna access lat, and I'm gonna check what the mode is, and that's the mode. And you can access it simply by putting by accessing its index over here, because this actually returns you a series object, and most of these will return you a series object. In any case, if you wanted to check the actual value, you can access it using its index, and there you go. Similarly, you can do the same with longitude, and that's long. And I might as well just make it nice by printing it. And there you go. That's the latitude, and that's the longitude where crimes happen the most. Okay, so now I'm going to talk about briefly about operations on categorical columns, or well, string columns essentially, right? So here it follows a very specific format where you put before you like. So say you're accessing a column, like let's say if I access column crime, and let's just confirm this is these are strings. Let me just look at the first value. See, that's a string, right? All right. So now with this, you'll have to put string first, and then you can put a string function. And most of the built-in Python functions will be available here. Now, the example asks us to replace all auto theft. So, okay, let's look at that again. So see, there's auto theft here and auto theft here. So it's going to ask us to check each row or each crime, and then we're going to replace any occurrence of auto theft from the string with grand theft auto. So I'm going to call replace string.replace auto theft with grand theft auto. Okay, and as you can see, it returns another series object, but in this case, it's replaced auto theft to grand theft auto. And you can imagine that you can do a bunch of stuff with this. Any string, most string commands you can use with this. Okay. And very briefly, I did also want to touch upon this, which is that operations work sort of similarly to NumPy, where if you try to perform operations on it, like multiplication or like some kind of Boolean operation, it's going to do it to every single value in your column or every single value in your data frame, every single cell in your data frame. Well, just as an example, let's say I multiply my column times 5. Okay, this might be bad. Okay. So for the string objects, it's just going to multiply it times 5. But for the string objects, sorry, for the int object, the integers, it's going to multiply times 5. But for the string objects, it's going to replicate it 5 times. But yeah, you can see it does it to every single value in the column. And that's something that you can also play around with on your own time. But okay, so now another useful command is df.t or transpose. So sometimes you're going to end up with a data frame which isn't as nice as this, where these column names are actually going to be under rows. So let me just show you what that looks like. And that is going to look like, just give it a moment. Wow, that's taking a while. Okay, okay, there you go. Okay, so as you can see, your row indices are your column names. So now this is kind of weird, but you may come across these, right? So just be aware that you can essentially flip the rows and the columns so that whatever are the indices on your rows will be the indices for your columns. And you can do so using df.t, which is very short, or you can also use transpose. But they mean the same thing. They're the same thing. And this might be very slow actually. Maybe shouldn't have done that. But this should give us back the original data frame if it would just finish loading. Okay, you know what? I give up on this one. So I'm just going to pretend that didn't happen. But you get the point. If I did that twice, it's going to result in the same data frame. Okay, so next is applying function across columns or rows. So now sometimes you need to start thinking about, can I use Pandas function in order to do what I want? Sometimes, and most of the time, your data is going to look so ugly that any built-in function from Pandas will need a little bit of tweaking so that you can do exactly what you want to do. So now, for example, we're gonna and you can do that using a couple of functions. The first one that I'm going to teach you is the map function. So what this is going to do is, given a column or a row, you're going to apply a function onto each cell in that row, and it's going to output another series object with the output of each function. Now let me show you what that looks like. Okay, so okay, let me just go to, okay, hold on. I think this is actually still running. I wonder if I can destroy it. Okay, I'm just gonna quietly delete that. Okay, I hope that, oh dear. Yeah, okay. I'll execute this session. Yeah, I think that, okay. Make note, probably not a good idea to transpose it twice, that might be a bad idea for a big data frame. But okay, anyhow, so the goal here in this example is to use map to extract the month each crime was committed. And then, so the first task here is to extract the month and then convert the month number to a name using this. Right? Okay, so if this would, let me just restart this very quickly. Bear with me here. I'm just having some technical difficulties. Okay. Now it's connecting. I'm so sorry about this, everyone. But should be good in a bit. But okay, let me just preface this though. The idea here is, okay, so this might be harder than you think. When you say use map to extract the month each crime was committed, we gotta look back. I'm not sure if I have it still. I might have, or maybe not. Okay, not connected to. It's odd. But a while ago, when I showed you, the dates looked like this: month, date, and then year, right? So imagine we have to process this string, right? So there's no, actually there are, but in order to process this string, you can create your own function, right? But what you'll need to do here is you'll need to first split this. You'll split this string into strings where you only have this, where you can identify this, right? This value here. And my approach would be, say if this was just it, right? I would split this string using this character. So I'm going to split this string into a list which will contain these three individual pieces, right? And then what I'll do is I'd index it at 0, right? So then what that would give me is this specific string. So now, if I was going to do that, I would use df date, right? So I'm going to call date. So I'm going to have a column of date. You can imagine that this is a column of dates, though it's not there. And then what I do is I'd map it, right? And then now I'm going to introduce something that you might be familiar with, but this is Pythonic. This is completely from Python, and it's the Lambda function. What it is you can create a function in one line using Lambda, and this would essentially be the same thing as saying define whatever x this. So this is essentially what Lambda x is, and then what you put in here is what you want to do, right? And wow, this is I'm surprised this is still not yet done. Maybe I can reload. Okay. In any case, I would map this. So what happens when I do this is that I'm gonna get every single every single row cell, right? So now imagine that this is what you're doing with. This is what you're dealing with. This is what x is, right? So what you'd be doing is you'd be splitting it by this, and then you'd be getting this. So what this is going to return to you is it's going to return to you a series object where each value in the cell is the extracted month. Yes. Okay, I can't fix that yet, but okay. Anyways, yeah. Now, after that, you're gonna have all the months, right? And now it tells us to use this dictionary to convert the month number to name. So we're gonna have these strings essentially, right? And now what you can actually do is you can map this again. You can map this again to this dictionary. Now you might be thinking map takes in a function, but the thing is, when you use a dictionary and you try to input a value into it, what you get is the output of the dictionary, right? So if you put in 01, then you're going to get January. And that's the same type of thinking that you should apply in this case. So it's going to take every single value on the row and imagine like this is the value that you get. And then it's going to map it. So it's going to put it into this dictionary and you're going to get January. So this is what it's going to give you is a series object full of October, and then September is down here. Okay, I wonder if I can do something about this. Wow. Connected to runtime. Well, that's very odd. Maybe I can try running this another. Okay, that's odd. Anyways, okay, I'm gonna. Okay, odd. Okay, let me just like hop onto this. It should be the same thing though. Should be, yeah, it's from where we left off, I think. Let me load in the data. Where is it? Okay. Maybe did I run it? Okay. Okay. All right. Now let's get back on track and wrap this thing up. Okay. So now maybe I can run this. And this, okay, month name. Okay. So let me just copy this here. But this is exactly the oops. This is what the okay, so that is the dictionary that we're going to use, right? So now if we map it, as you can see, this is exactly what I said. So now let me just backtrack very quickly just so that you can understand again what happened. So here it splits every single value from df df.date, it splits it, and then it takes the first part. So it's going to take this, right? And then it's going to map that again into this dictionary. And it's going to give you that. It's going to give you the month name. Okay, so now I'm going to move on to another thing, which is df.apply. So what you saw here with map, this you can apply to columns. You can apply this to columns. You can apply this to like any series object. So when you think of series object, you think of rows or columns, right? But with df.apply, what you're doing is you're applying it to the whole data frame, but you're applying a function to the whole data frame, and you either apply it to the columns or to the rows. Like you apply it row-wise or column-wise, right? And by default, the axis is 0, so it'll cause each input to be a column in your table, right? Okay, so in this example, it's asking us to create a column called coordinate system formatted by latitude, longitude using apply. So just very quickly, let me just look at the column. Let me look at the data frame. See, now you see it's lat and long, right? And what it wants us to do is it wants us to create a string like that. That looks like that. So I'm gonna use apply, and I'm gonna use a lambda function, right? And what I'm gonna do is first let me call axis equal to 1. And what this does, it causes each input to be a row. So now the input to this function, lambda, is going to be the entire row, right? And that row has these indices, crime name, etc. But okay, so now let me just quickly show an example. But if I do apply.xlat, it should just give me a column of latitude. And this is actually just the latitude column. So now we can use this, right? We can use this. Okay, you know what? I'll just create a font. So I'm just going to create a string for our purposes. And I hope you're familiar with this, but if you're not, this is just a way to format your string in Python using f, and then you can put in variables inside, and it'll just call it as if it were a string. Right? Okay, so now, I hope this works. but it should return to us a column of formatted by latitude and longitude. And this is exactly what we want. And you can just call it using df coordinate system, etc. Okay. Now we can talk about group operations. So now sometimes your data is going to have some particular grouping that you need to be that you may want to take advantage of. Like for example, in this case, you can use crime because there were only 11 crimes, right? And you can group these crimes, right? So that's the idea you should think of. And by default, you group by columns when you put in anything into by. If you put in a string, it'll use one of the columns, the string that you put. So if I put group by crime, it's going to group it by crime. But if I put in a list of, let's say, crime and then date, it's going to group it by crime and then by date. Nevertheless, the question asks, how many crimes occurred in each neighborhood? And what is the greatest number of crimes committed in each neighborhood? So here, it's clearly telling us that we need to use, we need to group it by the neighborhood, right? So then if we group it by the neighborhood, what we're actually looking for is the number of occurrences that we have. And note, when you use group by, it's going to actually return to you a group by object. And you can't really do anything with this because it's just grouped, but it doesn't have any specific like function just yet, right? So you need to apply it to a function. So it's going to tell you, it's going to say, these are the groups, and I want to apply to this. I want to apply this function to all of these groups, right? So now if we put count here and say, if I only go to crime, so wait, before I get ahead of myself, now that I put count, it's going to give us all the columns, right? So this is the neighborhood, and these are the values. And then when I apply count, these are the counts. And now I'm going to index crime, right? So this is going to give us the number of crimes committed in each neighborhood. And then to find the greatest, you can actually just put max here, like I showed a while ago. And this will give you the maximum number of crimes. So one neighborhood had this many number of crimes recorded. Okay, so next I'll be dealing with missing values. So missing values, as I mentioned a while ago, could be a none or not a number type of value, which just tells you that there is nothing in there, right? So if I go back to do to showing how many NAs are in this column, as you can see, there are this many NAs in this data frame. So now, what do you do with these missing values? The easiest thing that you can do is you can actually just drop the rows which have missing values and just treat it as an invalid record, right? So now you see we lost some columns, right? Because this is the maximum index we have, but we have just this many rows, right? So you can do whatever you want with this data set, but just also remember again that this is actually a copy, right? So your actual data set, even though you put drop NA, your data set's completely fine. So if you wanted to make sure that you drop the NA permanently, you can just assign it back again to DF, or you can use the parameter in place equal true. And this will actually modify your original data frame, and they'll drop the NAs there. I'll drop the rows there. And you can answer this question too if you'd like on your own time. Okay, so another option is that you can fill these missing values with another value. And you can do that using the df.fillNA function, right? So the question asks us to fill the missing values in the table with the most frequent value in each column. So this one is a little bit more involved, but if you remember, df.mode gives us a data frame, but in the first row gives us the mode of each column. And this is what we'd like to use. So this is just an example, but there's many ways you can do it. And now I'm going to use df.fillNA, and I'm going to use the mode. And I think this should work. Okay, so now as you can see, what actually happens here is that I fill in the mode. Actually, just to be safe, what I do is I would index the first row, which contains the mode. Like these are the modes, and then I would use fillNA to fill it in. And that should give me the same result. Okay, So now dealing with duplicate values. This works similarly to drop NA. So in this case, we don't have any duplicate values, as you can see here. And let me just sum it up. But as you can see, there's actually 0. So there's no duplicates in this case. But if you did have duplicate rows and you just want to not think about it, you can call df.drop duplicates. And it's going to drop all the duplicate rows in your data frame. And you can even specify which columns to check for duplicates using subset. But okay, and there's an extra section here for combining data, which I won't go into. But sometimes you're going to need to have to combine series objects and data frames for whatever work that you need to do, and you might be adding along rows or columns or what have you. And so there are multiple functions that you can use for that. And these are just to name a few: concatenate, join, merge. And I won't be covering it, but you can read more about it in this documentation. But yeah, congratulations. That concludes the Pandas workshop. And you can stop recording now. But now,